Alright guys, so for today's class I'm going to be using a video explanation to explain some solvings and calculations. So we have a question here in number 4 which says 50 cm cube of carbon 2 oxide was exploded with 150 cm cube of air containing 20% of oxygen by volume. Now which of the following reactants was in excess? Now this is a question relating to different topics. One of these topics from Gay-lussacs law and the other from air and pollution. So to solve this question, you need to know how to find the percentage of each composition in air. But first of all, we have to have a balanced equation for this reaction. Now how do we balance the equation? We first of all write out our reacting particles, which is CO, which is carbon dioxide, and oxygen. So this is our balanced equation for the reaction of CO, which is carbon dioxide, and oxygen to give us CO2. So you should take note that you have to balance the equation no matter what in the question. So we have 2 moles of CO and 1 mole of oxygen with 2 moles of carbon dioxide. So first of all, if you read the question very well, you see we have to find the normal percentage of oxygen. We are given just the percentage of oxygen that was used in this reaction, not the exact amount. So by this side, I gave a simple quick way to find the composition of oxygen in any case like this. So you have to relate it with its volume in air. We all know the percentage of oxygen in air is 21%, but this question specified to us that it is 20%. So that's what we are going to be using. So we are going to be comparing 100% to 20%. Simple comparison. If 100% of air contains 20% of oxygen, 150 cm cube would contain X. So by simply cross multiplying, you'll be having 150 times 20 divided by 100, which will give us 30 cm cube of oxygen that was used in the absolute amount in that Gay-lussacs reaction. So guys, since we have gotten the amount of oxygen, which is 30 cm cube, we can proceed to our equation. So at this point of the equation, we have 2 moles of CO, we have just 1 mole of oxygen, and we have 2 moles of CO2. Now what we'll do next is that we'll just place each volume of each gases below their moles so we can easily compare them. So that's what we are going to be doing next. So taking down the amount and the volume of CO down here, we'll be having 50 cm cube of CO, while oxygen, the absolute amount that we found here is 30 cm cube. So 30 cm cube. Now here for this, what I do is to find the excess, the one that was excess in this reaction, you have to compare both of them. Now you can see we have 50 cm cube here. If I take 50 cm cube to 1 mole, 2 mole is under 50 cm cube. When I take it to 1 mole, it means I'm reducing 50 cm cube by 2, or I'm reducing it by the factor of 2. So when I divide 50 by 2, we'll be having 25. But if I'm to move 30, which is under 1 mole, to CO, which is 2 mole, we'll be having 60. So for example, I decide to move this 30 moles to 50, we'll be having something like this. So here will now become 60 moles, while this 30 moles will come down here. Why did this happen? Is like you are taking 30 that was under 1 mole to 2 mole. It means you are multiplying by 2. While if you are taking 50 that was under 2 moles to 1 mole, it means you are dividing by 2. Now if you check, well, can 50 minus 60? No, that cannot happen. So what you do is that this cannot proceed. You have to try the other way. So we are going to try the other way now. Okay, the other way is simply taking the volume under 2 mole of CO to 1 mole of oxygen. Since we took 30 cm cube of oxygen mole, which is 1, to CO mole, which is 2, and it was not able to subtract it. So once we take 50 cm cube to oxygen, it will divide by 2, because we are taking something higher of 2 to 1. It means we are dividing it by 2. So at this point we'll be having 25 at this point, because 50 divided by 2 is 25, while here we'll be having 50, because the same mole will come down here since it's the same 2 mole. So at this point we can subtract. Here will be 0 mole and here will be 5 cm cube. So the answer should be C. Yes, the answer is C, because oxygen is in excess. Only 25% of the 30 cm cube was needed, leaving us with 5 cm cube. So we can come to conclusion that oxygen was in excess in this reaction.